Hello all, welcome to video lecture series on smart system design. Myself, Dr. C. H. Radhana Prasad, Professor, Department of ECE, SR University, Warangal. In this lecture, I am going to discuss about Arduino basic functions. Coming to learning outcome, after watching this video, you may be able to understand basic functions of Arduino. The Arduino software supports several functions. These functions you may be able to understand for writing your programs. The Arduino software supports several inbuilt basic functions. So let us see one by one. It supports basically four basic functions. They include digital I/O functions. Under digital I/O, there are three functions are available. They are pin mode, digital read, digital write, and then under analog I/O function, there are two functions are available: analog read and analog write. In timer I/O functions, there are two functions are there: delay microseconds. And last one is serial I/O functions. Under serial I/O function, serial dot begin, serial dot print, and serial dot read. These are the basic functions supported by Arduino software. Now let us start with digital I/O functions. Already in lecture 2, I discussed pins available, digital pins available on the Arduino UNO. There are 14 digital I/O pins are available on the Arduino UNO. And these 14 pins may be act as either inputs or outputs based on the device you are connecting to the corresponding pin. In order to configure that pin as input or output, the Arduino software is providing one function. That function is called as here pin mode. The pin mode is a function which configures the specified digital pin to behave either as an input or output. Okay. Then the syntax for this function is pin mode, pin comma mode, where this pin represents any digital I/O pin, and this mode represents either input or output. And let us see now this any digital I/O pin. Pin stands for any digital I/O pin, which is numbered from 0 to 13, and this mode represents either input or output. One of the example is pin mode 13 comma output. That means 13th pin is programmed as output. Another example, pin mode 13 comma input. So in this command, the 13th pin is configured as input. And coming to one more digital I/O function, digital write. This is also works on all digital I/O lines. They are ranging from 0 to 13. This function writes high means logic 1 or low a logic 0 value to a specified digital I/O pin. Let us see now syntax digital write. This digital write function having two parameters here. One is pin, another one is mode, where the pin represents any digital I/O pin which is ranging from 0 to 13, and this mode represents high or low. Either you can write high or low, or you can also specify with logic 1 and logic 0. So here the pin represents here any digital IO pin which is ranging from 0 to 13, and mode represents high or low, or you can also use logic 1 and logic 0. The example for this digital write is digital write 8 comma 1. This function will write logic 1 onto 8th pin. When you write logic 1 onto 8th pin, it will generate 5 volts at the output of 8th pin. And similarly, we can also generate 0 volts with the help of digital write. Digital write 7 comma 0 means the out we are writing logic 0 on 7th pin, but at the output of the pin we are getting 0 volts. So this is the use of digital write function. One more digital function is the digital IO function is the digital read. This digital read function reads a value from a digital input pin. From any digital input pin, if you want to read any data, we need to use digital read function. But the syntax for this digital read is we are reading the data with the help of digital read function. So that means you need to store in a some variable within the microcontroller, ATmega 328P microcontroller. So that means you need to define a variable with its data type. That means whatever the value you are reading from pin is stored in the variable. So, but normally here digital read means either you are getting 0 or 1. So that's why the data type for the um, variable is here int, and here the pin represents any digital IO pin which is ranging from 0 to 13, and the X is contains either 0 or 1 only. Then the example is here int X digital read 10 means whatever the input device is connected, based on that input device the X value may be either 0 or 1. This is the example, and this is the use of digital read function. Coming to analog IO functions, for analog IO function there is no need of programming is required. Why? Because they are separate lines, and by default they are acting as analog inputs and analog outputs. So we are having analog read and analog write functions only here. First we need to see analog read. This function reads the value from specified analog pin. If you are connected any sensor, that sensor value is read by this analog read function, and the syntax for this one is int X is equal to analog read pin, analog read of pin, where this X value is depends on this resolution. Already I mentioned that in lecture 2, all analog inputs A0, A1, A2, A3, A4, A5. These 6 inputs are of 10-bit resolution. 10-bit resolution is nothing but the X value is here 2 power n. 2 power n is nothing but 2 power 10. So 2 power 10 is nothing but 1024. That means the X may have 0 to 1023 possibilities. 0 to 1023 possibilities. So that's why here the X is also again declared as a data type int. Here the pin may be here any analog input that is ranging from A0 to A5, any one of the 6 analog inputs, and the X value may be in the range of 0 to 1023. And the example for this one is that means here it returns, the function returns an integer value in X that is ranging from 0 to 1023. And this is the example. If you are connected one sensor on A0 pin, this corresponding, based on the corresponding voltage, it will give a decimal number in between 0 to 1023 in X. Coming to another, uh, before going to discuss analog right, first we need to understand how it will generate the digital number or this decimal number. So let us consider this is A0 and this is analog sensor is connected on analog input A0. Then here we are having a voltage which is ranging. Analog sensor output is normally within the range of 0 to 5 volts. When it is ranging from 0 to 5 volts, it will generate a digital number within the controller, that is 10-bit number. This 10-bit number corresponding to 10-bit zeros is corresponding to 0 in decimal. And we all know that uh, resolution is equal to 2 power n minus, sorry, full scale deflection divided by 2 power n minus 1, where n is the number of digital outputs of the analog to digital converter, and here full scale voltage is the 5 volts. Why? Because the maximum voltage appears at the analog input is 5 volts. Then by substituting in this formula, V resolution is equal to V full scale deflection divided by 2 power n minus 1. Full scale deflection value is 5 volts. 5 divided by 2 power n. N is nothing but here 10. 2 power 10 is nothing but 1024. 1024 minus 1. So 1023. 5 divided by 1023 is exactly 0.0048. So this is the step change at the analog input. For every smallest change in the input may result in corresponding change in the output, one LSB change in the output. So if the voltage is in between 0 to 0047, it will be treated as 0 only. But whenever there is a step change, that means 0.0048 volts, then the value received, the 10-bit number received within the Arduino will become 1. So that means here we are getting decimal number is 1. Similarly, for double of 0.0048, we are getting 2, and so on up to 5 volts. So once the analog input receives 5 volts, it will get the all ones. That means 1023 value. Okay. So in this way, analog inputs are working. So analog inputs are normally connecting to an analog sensor. The analog sensor is having a step size or resolution of 0.0048. For this step voltage, there is a corresponding change in the output decimal number here. So that means here we are having total 1023 possibility voltages will accepted by A0, and that's why corresponding digital decimal numbers are received by Arduino UNO. So this is the operation of analog inputs, all analog inputs. Similarly, you can consider for A1, A2, A3, A4 and A5. Then we need to discuss analog write. Another analog IFO function is the analog write. This function writes analog value to an analog pin, analog output pin. Analog pin in the sense here, analog output pin. The syntax for this one is analog write pin comma value. Analog write pin comma value, where this pin value represents 0 to 255. Why? Because the analog outputs are of 8-bit resolution. 8-bit in the sense 2 power 8. 2 power 8 is nothing but 256 possibilities. That is considered from 0 to 255. And the pin is any analog output pin. So already I mentioned in lecture 2, 3, 5, 6, 9, 10 and 11. These are by default they are acting as analog output pins, and based on the voltage requirement we need to write this number in between 0 to 255. Suppose if you want to write the 5 volts, you can use here 255. If you want to get the 0 volts, you need to provide 0 volts. Based on voltage calculation by using mm, resolution formula, you can compute, and we can generate different voltages on the analog output pins. The working, let us see now how it will generate the voltages. We will see now. Let us consider here I am taking analog output 3, and before this sign is nothing but it is a analog output. Now, if you want to generate 0 volts, I need to provide initial decimal number is 0, but actually it is 8-bit number. And similarly, by calculating this step size for analog output, we are getting 19 millivolts. So that means for every 1 bit change in the input may result in there is a change in 19 millivolts. That means 0.0195 volts. Okay. So if you are provided this decimal 1 is nothing but you are getting a voltage of 0.195. Similarly, if you want to get the voltage of 0.390, you need to send 2, decimal 2, and so on. Like this, you can send the numbers. Based on our requirement, we need to compute this, and we need to generate the voltages on analog output pin. If you observe here, all ones is nothing but 255. 255, when you write the 255 onto third pin, so it will generate a voltage of 5 volts. Then coming to timer functions, in some applications we need to uh, provide the delays in between the actions. So in order to provide this, the Arduino software itself providing two delay functions. One is delay. This function passes the program for the amount of time specified as a parameter. The time should be in milliseconds. So let us see one example here, syntax for this one, delay milliseconds. So let us see the parameter millisecond, the number of milliseconds you need to pass. Here millisecond is a parameter, so which will passes your program for milliseconds. Suppose for example, it will not return anything, but suppose if you provide if you want to stop a program for 1 second, you need to provide 1000 here. So 1 second is equal to 1000 milliseconds. So that means 1000 milliseconds corresponding to 1 second. Based on our requirement, you can change this parameter 2000, 3000, 4000 and so on. Based on our delay requirement, you can change this parameter. But here this parameter is in milliseconds only. Then coming to one more timer function, that is delay microseconds. The only difference between previous one and this one is here parameter is microsecond, and here it is completely differentiated with the help of this command delay microseconds, and the syntax is delay microseconds, and the parameter is microseconds to pass and nothing to return. And the example, if you want to provide some microsecond delay, you need to place some value within the parenthesis. Coming to serial IO functions, There are three functions are there. Let us discuss one by one. Serial begin. This is normally when you are using a serial communication. So first you need to set the baud. Number of bits you are going to transmit from Arduino to some other device, or to receive the data from other device to Arduino. So we need to set that baud. To set the data rate in bits per second for serial data transmission, this function is used. So let us see the syntax. Serial dot begin. Here, whenever there is a dot is available before after the word, the first word first letter should be capital, and serial dot begin, within the parenthesis you need to define the baud. Suppose normally the serial ports supports different baud rates, 100, 300, 600, 1200, 2400, 4800, 9600, 19200, and so on. So based on our requirement, based on our device, we need to provide any value in between 19200 as per our requirement. So the parameter is speed here in bits per second. It will not return nothing. And coming to another serial IO function, serial.print. This will print the data to the serial port as human readable ASCII text. That means whatever the your data is sending, that is printing on serial port of Arduino. And the syntax is serial.print val. Means here val means whatever the, this val means here variable. Whatever the value contained in this variable will be printed in this case. Parameter is val. Uh, so the value will be printed here. And whenever if you are using like this, serial.print within double quote SPD. In this case, it will not be a variable, it is a string, so it will directly print it as SPD only. But in this case, whatever the content is available in val variable is printed. And you can also use ln as a character is written in order to print in next line. And next function, this ln normally used to print the next line. And last one is serial read, which reads the incoming data from the serial port of the Arduino. So the syntax for this one is serial.read, and the parameter is serial port object, and the return value is the first byte of incoming serial data or -1 if no data is available, or minus integer. And the syntax is actually we need to write like this: char x is equal to serial.read. So with the help of this command, we can read the data from serial port, and it only receives only first incoming data as a character. If nothing is received, it will return -1. And suppose if you want to read the integer values, in that case you need to use the serial.parseInt. Serial dot parse int. Parse capital I NT function. This is the function is used to read the integer values. So in this case, it will read integers. Let us consider int x is equal to serial.parseInt, but here it will read the characters. So based on our requirement, either you can use integer or serial. So thank you for watching. Please like, share, and subscribe.